Hello guys, so today I'll be solving this problem which is binary prefix divisible by 5. So the problem states that we have been given an binary array nums and we define x of I as the number whose binary representation is the subarray of nums of 0 to I. Okay, so whatever prefix I'm getting from 0 to I, so it will have a binary number, and if I convert that binary number to a decimal number, so whatever number I'm getting, so that is my x of I. Then so yeah, here is the example. So for example, I have 101. Okay, so when I start with 1 only, okay, so uh, this is by this is 1. Okay, so I'll consider 1 in the decimal representation. Then I have 10. Okay, so so this in decimal representation, it will be 2. Okay, and then finally I have 101. Okay, which in decimal representation will represent 5. So yeah, these are my x of i's, and finally I have to return an array of booleans where answer of I will say that if it is, yeah, so answer of I will be true if the x of I is divisible by 5, whether these numbers are divisible by 5. So here answer of I will look something like this. So for the first element I have 1, so 1 is not divisible by 5, so this will be false. Then for answer of like 0 1 2, okay, for answer of 1 I'll be having 2 as my decimal representation, so this is not divisible by 5, so I will be writing a false here. Then finally I have 5 here which is divisible by 5, so I'll be writing a true here. So yeah, for this case this will be my answer array. So yeah, this is the problem statement. Now this is a so by looking at the problem statement, it looks very simple. So every time we just need to calculate the binary representation of our current prefix. So if we start iterating over this nums, and we will simply check whether that prefix is divisible by 5 or not. But the caveat here is the nums length. Okay, so nums length is 10 to the power 5, which basically says that I will be having 10 to the power 5 bits to represent a decimal. Okay, so how this is problematic, because so if there are 10 to the power 5 numbers, so let's say 0 1 1 1 some 1, so let's say this is 10 to the power 5 numbers. Okay, now if I try calculating this whole number's decimal representation, okay, so it is, so there is no data type that can store the decimal representation of this value. So yeah, so we need to think of some smart way. Okay, but yeah, before doing this, so let's do it in a naive way. Okay, then we will see if we can improve that idea. So yeah, what we will be doing, so we will be having some kind of a variable, let's call it prefix. Okay, so at first I will initialize it to 0, then I will iterate over all the elements. So I will be enumerating, so I'll get my elements. Let's say enumerate of my nums. Okay, and every time when I am so every time I will be updating my prefix value to something like this. So prefix uh, will get multiplied by 2. Okay, and I'll be adding up whatever number I have currently. Okay, so this is how I will be building the prefix decimal representation of my prefixes. So yeah, so and then I'll be checking if my prefix is divisible by 5. Okay, so I'll be updating my answer of I to true, provided I have initialized my answer to boolean array, false, 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 n times. So yeah, this is kind of a pseudocode. So yeah, if we overlook at this constraint of 10 to the power 5, this code will work. So I'm starting with a prefix of 0. Now every time I'm multiplying that prefix with 2, okay, and I'm adding up whatever number I'm getting in my current nums, okay. So by this way I'll be updating my prefix and I can keep going, okay. So now if we look at the constraint, okay, this I will be some 1000, 10,000, or maybe 10 to the power 5. So this prefix will always be in a increasing order fashion, okay, and at like 64, and when it goes beyond 64-bit level, so it's pretty difficult, or maybe like 128-bit level. So now it will be difficult to store this number in a variable. So yeah, so now let's think what we can do better, okay. So let's ask this question: do I need to store the entire prefix, okay, in order to satisfy this condition, okay? Do I need the entire decimal value? So the answer is no. If we simply know the modulus, okay, of our current prefix, and even with that modulus I multiply it by 2 and I add up new number and then I do a modulus over that, so that will not change the modulus of this thing. So what I'm basically saying is, so after this update my prefix will be updated to this value. So prefix into 2 plus nums of I, okay. So when I'm checking to update my answer, what I'm doing is I'm basically checking whether prefix mod of 5 is equal to 0, okay. So now let's update or let's perform this operation here only. If I do a mod 5 here, okay, now let's do a bit of math, okay. So here I can like perform the distributive property of modulus. So this will look something like this: prefix prefix into 2 mod 5 plus nums of I mod 5, and overall I'll be having a mod 5, okay. So this is the distributive property of modulus, okay, for addition. So yeah, now my nums of I, so let's solve for this part, okay. My nums of I can be either 0 or 1, okay. So whatever value I'm getting, it can be either 0 or 1. So it's already in the modular range of mod 5. So yeah, this will directly give me nums of I, okay. Now let's look at this part, okay. So here I have a multiplication also. Now let's again do the distributive modular arithmetic. So this part will look something like this. So prefix mod 5 times 2 mod 5, and we need to do a overall mod 5. So yeah, now if I solve individual elements here, so this will be prefix mod 5 times 2 mod 5 is 2, and I have an overall of mod 5. So yeah, so when I'm doing this thing earlier, okay, at this part, so this is essentially this thing only. So if I simply check prefix mod 5 times 2 overall of mod 5 plus nums of I and mod 5, okay, this will result me in prefix mod 5. So yeah, so when I'm storing or when I am updating my prefix, I don't really need the entire decimal representation. I can simply store the mod 5 result of my prefix. And even if I'm doing multiplication and I'm adding up numbers, when I'm again doing the modulus of 5, it will store my final result modulus only. So yeah, so with this my prefix will never my prefix will never be beyond than like very large number, so I can always represent it with integer data type only. So yeah, that's the idea. So yeah, after this I can simply check this value whether it is equal to 0. If it is equal to 0, then I will update my answer. So yeah, that's the idea. So let's code it up. So I'll be storing n, so nums of size. So at first I'm doing for C++, so then I will be creating my answer answer array. So this will be answer of nums of I need boolean, so bool of answer of n. Then I need to iterate over all the elements now. Okay. Then I will be creating my prefix. Okay, prefix decimal representation. Then in the end I will be returning my answer. So here what I will be doing, so I will first multiply my prefix by 2, so pre mod 2 like times 2, and I will be adding up whatever result I am getting in my current iteration. Okay, then what I will be doing is I will simply doing prefix mod 5. Okay, now I will simply check whether, now I will update my answer value, answer for my ith index as pre is equal to 0 or not. If it is, then that means my current prefix is a multiple of 5, so it is divisible by 5. So yeah, like that I will be updating my prefix. If I run it, it will pass all test cases. So yeah, this is the crucial step here. So if I don't do this, okay, and if I simply check here mod 5 is equal to 0, okay, now my prefix will go and go, okay, and for a 10 to the power 5 size of test case, so it will overshoot my integer data type. So if I run this, and there are some cases where it can max out, so for initial test cases it will work, but if I try to submit, this will fail. So because here if we are seeing, so what can be happening is, so but because every time I'm multiplying it by 2, it is going to a very large number, so it can happen like it is it is getting clipped off by my integer max value. So because of that the results are not accurate. So yeah, but if I do this and I simply check whether it is 0 and I submit, so this will pass. Cool. Now let's quickly do it for Golang. So n len of nums. So then I will create my answer array, so which is this, make of int of bool of n size. Then I will create my prefix, which is this. Then I will iterate over all the values, I, then le in range of nums. I will update my prefix. So the same code what I did in C++. This time this is le, and I will update my prefix. So I will only store the modulus 5. Then my if pre equal to 0, then I will store for current index 2. Otherwise, yeah, and finally I will be returning answer. Cool. Now let's finally do it for Rust. So I'll be storing the length of nums, so which is nums of len. Then I will be creating my answer array, so which is I will be creating as a mutable array. So this will be vec of size. So yeah, initially all of them are false, and I will create it of size n. Then I will create my prefix array, which is again a mutable value, which is 0. then I will iterate over all the elements. So for I in range n, and finally I'll be returning my ans, and yeah, here I'll be updating my prefix. Then pre is, so here I'll be adding up my nums of I. So I multiplied it by 2, added up nums of I, then I will be storing the mod 5 result, so only the remainder. Now I'll check if pre equal to 0, then I will update answer ith position value to true. Cool. I can shorten up this code by moving this guy here, so not writing this if condition, so this will also work. So yeah, for rest this also passed. So yeah, this is the logic. So we only need to store the remainder after we have divided with 5. So basically the modulus of 5 for our prefix. We don't need the entire prefix or the decimal representation in order to solve this problem. So yeah, so I hope this video was helpful, and I was able to give you guys the concept you need to solve this problem. So yeah, just stay tuned to watch more videos, and if you like this video, please do like and subscribe my channel. So yeah, thanks, bye bye.